Today we will see something about like in our last class we have discussed. We will see some accessories. So let us see what are some important accessories used in firefighting. So I have just taken one list for that. First we will see these accessories and later we will see some schematic drawings also. Okay. So normally the types of pipes which are used in firefighting system, like normally it is something like scheduled 40 pipe or sometimes schedule 10 pipe is also used, but most of the time we use schedule 40. So what is schedule 40? So just remember the MS pipe or GI pipe. It is nothing but the schedule 40 pipe. And even in our Elite software also, we select the same category of pipe, schedule 40. Okay. And I've just taken one typical example. Okay. And here there are different types of pipe actually. You can go with carbon steel pipe, MS pipe, GI pipe, depend upon that. But the major name is like schedule 40. Applications also you can see fire sprinkler, fire pump pipe, fire pin pipe. There are so many applications. So this is one of the type of accessories.
Carbon steel is GI or
No, carbon steel is a different pipe. GI is a different pipe. MS is a different pipe. MS is mild steel, GI is galvanized iron, and carbon steel is CS pipe. Okay. And there is one more pipe, cast iron pipe we have seen yesterday. So in the foam system, they are using cast iron pipe. Okay. So this is normally about the pipes. You will get the technical details from the manufacturer because there are so many technical details in pipes, like what is the stress and like what is the weight of the pipe. And there are so many things. So how much like dimensions lengthwise, what is the standard length, width, thickness, everything will be given by the vendors. Okay.
Mr. Atif, there is also schedule 80 pipe. I think the difference from schedule 40 is the thickness of the pipe.
Yeah, schedule 80 is greater. The thickness is more in schedule 80. Schedule 40, the thickness is a little bit less, and schedule 80, the thickness is more. In the same way, there is schedule 10 pipe also. So schedule 10, schedule 40, schedule 80.
Normally, mainly we are using schedule 40.
Yeah, schedule 80, I think we use in like plumbing when we go for the domestic, sorry, not domestic, in the drainage, whenever you are going for the critical drainage. So that time they will use the schedule 80 pipe. Some sizes are written like standard. You will get the standard data from the manufacturer. They will give you, this is just the classification of the pipes according to the weight, thickness, or any other thing. But these are the like MS pipe, galvanized iron or CS. This is the what you can say the material. This is the material classification. This is the pipe classification, like pipe technical classification. Like that, you can understand this. And in the same way, there is one more, like I have just written here, GI ERV pipe, ERW. So this is the galvanized iron pipe, and different names are given actually. And okay, here it is written wall thickness. So this can get in schedule 10, 30, 40. Okay, and here the most important thing is the fittings, like which type of fitting you are going with. Okay, one is like your butt weld fitting. So normally in fighting, you will see there are 2-3 types of fitting, like groove fitting or butt fittings, and sometimes welding is done. So even this particular thing will add up.
But okay. This butt weld fitting, it is for the HDPE, right? HDPE.
No, this is for in general. This is in general. I'm talking in general. So just see the butt weld fitting, and this is how the finishing comes. Now what happens in butt weld fitting? Just you can see, take any one section. Okay, suppose this you are taking one pipe. So if this is a butt welded, okay, so what happens when you want to connect some pipe section here? So you have to use one more what you can say, anything you have to use. Either you have to use the solvent or pay or sometimes you have to use any caps, something. So sometime what happens if you are going with this butt weld fitting, so there may be chances that your friction loss may occur. Okay, why means because in butt weld fitting, what is happening? we are taking one pipe section and directly we are attaching to that pipe section. Okay, this is the butt weld which is applied here. Okay, so this is one thing. I will.
This is welding, boss welding,
Yeah,
fusion welding.
everything will be done in welding only. But this is the
But welding mean face to face. They join the pipe or fitting whatever, and then they weld around. So this is
yes,
called welding, and there is overlapping. It's not used here. So mostly
exactly.
welding only.
So this is one type of the fitting. So normally, like you need to check whenever you are doing the projects, you should check the requirement of client, whether they require the butt welding or the groove fitting. And another one is the threaded fitting. In the threaded fitting, what happens? Near the edge of every pipe section or the fittings, there will be a thread. Now this thread will again give you some compact, what you can say, it will again give some resistivity, or you can say it will hold the other material. Suppose for example, if this is my one of the pipe section, so because of the thread given here, so my another material will be folded very properly. So you can say that this particular fitting will give us stiffness as compared to butt welding. So here the chances of friction drop is a little bit less as compared to butt welding. So obviously you should understand that whenever the threaded welding is coming, the cost will little bit increase because we have to give some thread in the outer section of any pipe or fitting. So this,
And also, I think there is a restriction here, up to 2 inch, 2.5
yes,
inch. You can use this.
yes. There is a restriction. I think 65 mm, up to 65 mm, we can go with threaded fitting.
Yeah, 2.5, I think.
Yeah, 2.5 inches, because actually our main focus is for 25 mm, 32 and 40 mm, because these are the pipes which are used in abundant actually in any project. So you will find that the major quantity is for this pipe 25, 32, 40. So that's why nowadays, just to avoid some cost cutting, they are going with the CPVC pipe for these particular pipe sizes. Even I think 50 mm also they are going with CPVC pipe. And here client will ask threaded fitting. Why? Means because these are the pipes which are going to run in our inside of the building. So that's why they don't want to go with the butt welding, but they want threaded welding. There is one more fitting, which is, see, these are some examples how the threads are made here. So you can see this. There is one more socket weld fitting. So here what happens, one, it will be like a socket. So one, in one part, another part will enter. So it will act like a socket. So
This one bush, we call it bush fit type. Bush fit type.
yeah. So here you can see the inside surface is very finished here. Okay, and here this thing you can see. One thing is like here they have written the insert. That means it is inserting into this particular fitting, and this is how it will become the elbow. After inserting, this elbow will become. So socket weld fitting again, it might be like it can give the good results as compared to threaded fitting, because in the threaded we have to just make threads, and here again you have to go for the very good finishing, and you have to go with the socket weld fitting. So this is also one of the type of fitting, and these are the some socket welded. So how you will understand, means just by seeing this inside surface or finishing, you can understand whether it is a socket weld or threaded fitting. There is one more groove fitting. So even groove fitting also looks like a threaded fitting only, but here also the same thing happens. Like it will like one piece will enter into the another piece, and they will interlock it. So again, these fittings also will give us the good friction.
This is 3 inch and above. This one 3 inch and above.
Sorry.
This is grooving fitting for 3 inch and above size pipe, not for 2 inch and 1 inch.
Yeah, you can for the main header pipes, if we are going for the main header or main riser, even
it will be grooving
yeah,
type, this one.
groove type. Okay, so the butt welding is like probably we have to avoid butt welding fitting, because here in firefighting we cannot take chances. So that's why whenever you will see that whenever you are discussing with the client, so you need to understand what is the type of fitting client is like asking, whether it is a threaded fitting or a groove fitting. So obviously this groove fitting will again go a little bit higher on side. If you compare threaded with groove fitting, so the rate of this groove fitting is a little bit higher as compared to threaded. But if anyone is like using butt weld fitting means their cost is very very less, because butt welding we don't have to do anything, just we have to join two pieces and we have to do some welding here. So remember that this fittings,
Both welding by solvent weld, or welding by arc welding and diffusion using
any
electrical machines.
anything which is available with the like contractors,
Mostly electric arc welding.
electric arc welding will go, because here we are talking about joining the like iron pipe. We are not joining the plastic pipe. In plastic pipes you can go with the like solvent type also, but
Yeah.
whenever you are joining any iron or steel pipe, it cannot hold actually. So
There are two types of pipes, ARW and seamless, right?
yes, yes, ARW and seamless pipe. So ARW is one category which comes for, like every pipe will come under ARW only, like MSGI CS pipe. So these comes under, yeah, there are different classes actually, classifications. So we don't need to enter into the classification, because obviously when you see the BOQ technical details, the whenever you contact with the manufacturer, pipe manufacturer, they will give you each and every technical detail. But fittings, they will ask which type of fitting you want. So you should understand, you should know that whether you are going with threaded, grooved, or socket welding. So this is the thing which as a designer we should have a knowledge. So here some of the images given here, how this fittings looks like, and some images given here like
This
group.
is also called Victaulic fitting. No?
Yeah, Victaulic fittings. So this is one company, Victaulic. So they are the one, I think, who has like invented or produced this kind of fittings. So normally this fitting only will like run in the market, and every fitting should be, or whatever the pipe we are selecting, or whatever the equipment we are selecting, it should be UL listed or FM approved, because we are talking about firefighting here. So every material, every equipment should be UL listed actually, at least UL listed. UL is nothing but one underwriter's laboratory. So
American, USA standard.
yeah, American, not US, it is UL listed, underwriter's laboratory.
It's American, boss, American.
Yes, yes. And FM, I think this is FM Global. So there are some certain.
I'm from Germany. I'm from Germany.
Okay, yes. And here something is given here, groove threaded. Just I have taken some images here. Pipe hangers and clamp. So here you can see some images on the hangers. So normally we require hangers also. Why means because when water is running inside the pipe, so there may be chances that oscillation may occur. Okay, because the water is moving with the velocity and with the high pressure, so some oscillation occurs. So we require some clamps also. Now, how you are installing clamps, that you need to check. Like I think every 6 feet they take one hanger, or every 8 feet they will take. So it depend actually. So project to project, sometimes they are taking 4 feet, 6 feet. Okay, like that they will they will hang this pipe with the help of some clamps here. Different types of clamps are available.
But boss, this is not for hanging. This one for the seismic study. This one.
Yes, yes, this is the pipe supports. Like just to support.
This one, the hanger
ceiling.
support. To your left is for the seismic study. To your left.
Yeah, yeah.
I think earthquakes and these things.
But normally we why we are using this pipe hangers and supports, to support the pipe, because we have to like hang the pipe. We don't know till how much time we are hanging that. So okay, this is also one of the reason like supporting structures and all. But majorly what happens if we don't hang properly, so there may be chances that oscillation may occur. So this is what the pipe hangers, and here you can see some types of hangers are given, some models, different type. So whatever is suitable, you can go with. Just I have taken some images, and I think every 6 feet, they will, like, every contractor will have their own set of what you can say,
every 2 meters, usually every 2 meters.
2 meters, every 2 meters, or
Yeah.
8 feet, every 2 meter, 1.5 meter, depends actually. And HDP pipe joints in firefighting. Just some like fittings and all is shown. Plastic piping. Suppose if you are going with the pipe, plastic pipes. So one drawing is given here. Fire water hydrants. How the fire water hydrants are installed. Just one example I have taken. So how these pipes are, normally everything is like given in red. Whenever we are talking about firefighting, every thing we have to paint in red actually. So maybe this red color, because it will be visible very easily with our eyes. So that's why we have to.
No, boss, it has fire coatings, 3 coats for fire coating. The last coat is red. It is fire rated coat. This is this one.
Yeah, because even in when you go to the chilled water also, so in the chilled water also they will have some different color coatings. But when you see the firefighting, everything will be in red color only. Fire hose cabinets, fire extinguishers, and even the pipes, everything in red color only. Next, some images, fire hose. How does the fire hose looks like? Okay, zone control valve. Suppose whenever we are going with the zone control valve, this is a schematic drawing for the zone control valve. So suppose if anyone is asking you to draw the zone control valve, this is what we have to draw. This is the main riser pipe, and this is our like inside pipe. And to this section only, here we have to connect the drain pipe. Why here we have to connect? Suppose if we want to maintenance work
to drain water because of
floor,
maintenance.
to drain it. Yeah, and here pressure gauge will use water flow switch will be installed. Now remember that this water flow switch size should be exactly the same size whatever our pipe is going inside the building, inside the floor. So this pressure switch we have to take. And one more image is also given here. See, this is also the same image. And here what is done means one OS and Y valve is used here. There is one valve OS and Y. So that is installed here. This is also zone control valve. So different what you can say, consultants will use different methods. So this is something is given here. Alarm check valves. Now what is this alarm check valves? Because of this alarm check valves only we will get if any fire occurs in any place. Suppose if the fire is occurring in 5th floor at particular anyone's sprinkler or any one area, so the smoke detector will detect and they will give the alarm. So that alarm will first come to the alarm check valve. Once this alarm check valve receive the signal, then it will again send a signal to the fire pump. Fire pump will activate and it will like draw out the water from the underground tank.
Boss, I think this is mechanical alarm. Whenever water starts flowing, it start belling, alarming.
Yes, boss, it is mechanical. Once
Yeah.
once the spring start releasing, it will work. This one, it will the bell will ring.
Working with
The
water.
pressure switch will give signal to the
But
fire
yes,
alarm
yes.
control panel. Yes.
But actually, whenever this is the controlling this, you can say that this is for the controlling purpose only. So obviously, we get alarm from the smoke detectors only. So the smoke detector will alarm. Maybe the smoke detector will send alarm to the control panel, and from the control panel again it will come. But normally this alarm check valves will be installed in the main sprinkler line. So I think as you are telling, like it is used for the water supply, but just understand that when the
This mainly this bell, it's called gong bell. It's
yes,
installed in the fire pump room. So if operator is sitting there, so he will know that water starts sprinkling. It started, the pump will start everything. So with water flow, it start belling. And the same time, electrical system, it's separate with this. So this is
yes,
only
it's pneumatic
any
system.
water is flowing now.
Yeah, yes, maybe because this system will activate only when any fire occurs. because obviously whenever there is a fire, or maybe during the time of maintenance, so whenever they are doing any maintenance work, so it may alarm. This is also called as sprinkler valve also. Sometimes they will also call it as sprinkler valve. And the size of this alarm check valve remains same whatever our main header size. Suppose if we are using 150 mm pipe, so we have to install 150 mm only, because this size matters, whatever the size is given here. So we have to directly install on the main pipe. And apart from that, okay, here they have given the positioning of the alarm valve. This is the test valve, water monk, pressure switch, normal condition, supply pressure, system pressure, something is given here. I think one more image is okay, only this image is given. So just one what you can say, one schematic type is given here, how and where they have placed the alarm valve. After that, some sprinklers, some images for sprinkler, upright pendant, vertical, horizontal, recess pendant. Some sprinklers are shown here, and with temperature rating and some definition, orifice, threading, plug, and this is the liquid, and here the temperatures are given, temperature ranges, frame, deflector. So just in one image, everything is given here. And some typical wet pipe sprinkler system is connected. It is shown here how the system is connected: water motor, alarm, check valve, fire department connection, main drain, water supply, automatic sprinkler. Some in the same way, one dry sprinkler system is also shown here. So in the dry sprinkler system, everything remains same, but this particular everything is air pressure. And here might be they are using one gate valve to control water supply to system. So whenever the fire occurs, this gate valve will open and water will start entering here. Just one image is shown here. Typical deluge system, how the deluge valve and all the open sprinkler heads are connected here. Detectors are shown here. Foam proportional, maybe this is the foam deluge system is shown here, because here they are talking foam concentrate or foam proportional. Deluge valve in action. And OS and Y, this is what, inlet, outlet. Okay, this is also deluge valve operator. Some image I have just put here about the deluge valve. Fire hose cabinets, landing valve. Okay, this is the landing valve which is connected with each and every fire hose cabinet. This is also fire hose cabinet, fire hydrant or yard hydrant. Like outside, you will see this kind of yard hydrant. And single headed fire hydrant, stand post, double headed. So single headed means only one pipe can be connected. Now this particular you see, this is nothing but the one we are discussing, 65 mm or 40 mm. So here the pipe will connect actually 65 or 40 mm. So that is what is given here. And this is one example. This is the fire hose cabinet and this is the stand pipe. Okay, here the pipe will enter, okay, like 65 mm or 40 mm, and here the hose will be given, hose reel. Just we have to take out the hose reel, and wherever the fire occurs, just we have to extinguish the fire. So this rubber, you can see this particular RRL hose, it is sometimes 15 meter, 30 meter, 36, 40 meter, depend upon the size of the building we can take. And dry rising pipe, just one thing is shown, fire brigade team, and this is landing walls, firefighting shaft, some things are just shown here. Fire brigade inlet, normally it is 4-way or 2-way. So this is FBIC, or it is also called as breaching inlet also, and sometimes breaching inlet is, it is also called as breaching inlet or FBIC. So this is how it looks like. And normally this thing we will see near the what you can say, near the entrance of the building, or anywhere in the what you can say, near every like you will see in the outside of the building only. Okay, outside of our premises only we will see this fire brigade, because the firefighting team will always look for this inlet only, breaching inlet. And the moment if any fire occurs, the firefighting team comes and they will insert pipes here. First they will insert, now there are 4-way means it can go to the 4 places, you have to connect to the 4 places. Like one you are connecting to any near the tank, and one you can connect to the main header line, yard hydrant, anywhere you can connect. Sometimes they will connect to the bore system also, or sometimes they will make it they will keep it empty also, if you don't have to use this. SAM is connection FDC. So this is how the pipes will they will come and put the pipe here, and here in the FDC it is called as Siamese connection. You will see this kind of connection also, where the firefighting, not this particular thing should be always visible to firefighting team, because they will be looking for this connection only. Whenever any fire occurs, they will look, first they will insert pipe here, or sometime you have to fire brigade inlets will be there. So I think both the things will be placed nearby only. And this is one typical image fire department connection schematic. Electric fire pump. So this is the electric fire pump, diesel fire pumps. Just some image I have taken. Jockey pumps. Jockey pumps looks like submersible pump only. It's very because the capacity of jockey pump is very less. Okay, 180 lpm or 240 lpm, like that. Small capacities will be available. You can get the details from the vendor also. What are the fittings used in pump suction line, pump discharge line? Just I have written some points here. So OS and Y valve, outside screw and yoke valve or rising stem valve, flexible connection, reducer, suction pressure gauge. So some we will see that in our schematic drawings. So whatever the fittings or valves are used there. Bypass loop in pump room. A bypass has two control and one check. The bypass is used when water is supplied from a city supply. A bypass is not required when water supplies from a tank. Okay. So just something is written about the bypass. Only we have to use this bypass whenever the water is supplied from any city supply, municipal corporation. And if you have the tank or anything, don't go with the bypass system. So this is some point is written about the bypass. And this is also, I have just taken one image. So it looks very good actually. Fire pump, jockey pump, suction line, discharge line, how it is going to Siamese connection. Some it is going to the test header, fire control panel. Here only it is not shown, only for the fire department connection is shown here, not to the entire. No, this system is going to the main sprinkler system. Just one image is shown here. This is also one image is shown here. Okay, two system. Like that, you can see some different flow switches. How the flow switches looks like. Pressure switch, which is used in the zone control valve. This is how some of the models is shown here. Okay, so these are certain accessories, but as a designer we should know at least there are so many accessories which should be known to us, but majorly we should know about the pipes. Okay, and which type of fitting we are using, because as a designer we should not leave this section fittings, because what happens, this fittings sometimes your cost, for example, if you are buying a cost of for example $10,000 is your pipes cost, for example, sometimes what happens, this fitting cost will go up to 25%. I'm talking about in general, or sometimes because of our poor designing, poor selection, it can go up to 40% also, 40% of $10,000. Just imagine what will be the impact if my fitting cost is increasing. So that's why we have to always focus on the fittings, and sometimes we should always also focus upon that hangers and rod also, because sometimes what happens, if you are using unnecessary hangers and rod, so it will also cost us some extra amount only. So these fittings and hangers and rod, these are non-tender items actually. It is NT items. NT items means it will not include in our costing. So if you, because of our mistake, if we are not selecting proper fittings, proper hangers and rods, and proper this thing, then what will happen? The company has to bear the cost. Okay, so that's why the drafting of this whatever the piping is very important, because if we draft it properly, then so many things can be saved. Like we can avoid some fittings, we can avoid elbows, T's or cross, and we can avoid fittings, hangers, rods. So that's why we require a lot of practice for doing the sprinkler selection. Sorry, the sprinkler rotting requires a lot of practice. So you have to just see so many projects, then you will understand, and you can like uh, go for very reasonable what you can say layouts, because sometimes what happens, our equipment cost is less. What is the meaning of equipment means, like for example fire pump or any FHCs, fire hose cabinets, or jockey pump, or what you can say pipes. I'm just talking this in terms of equipment, but when you go for fittings, the cost will go a little bit higher. Why means because of our improper or poor designing. So that's why designing is very important. You have to avoid uh, maximum fittings in your design. Wherever you can avoid the fittings, you should avoid it. Otherwise, what happens that those small fittings will add to the main what you can say main sheet, and then the cost will also increase accordingly. So also I will show you some schematic drawings. Just I was taking some schematic drawings. I will just show you. This is how they like this drawing. I find it very suitable, and it's very simple to understand also. Like here you can see the tank is shown here, fire water tank, and maybe this is the line which is coming from the municipal corporation. And here you can see this is our main firefighting line. One is the suction pipe and one is the delivery pipe. So always remember this concept.
No, boss, we have two suction line. Our civil defense need water tank divided into two halves and two suction. They will never accept
No,
one suction.
leave about that suction and discharge. Just understand this thing. Whenever the pipe, whenever the water is coming out of the pump, will be our discharge. The incoming is our suction. Okay, this is the very basic thing we should understand in pump. So, and whenever you are drawing the schematic drawing, you have to draw in this pattern only. This symbol represent that the water is going in this direction. So this is our discharge line, this is our suction line. So always you should understand where is my suction and where is my discharge. So now just by seeing this arrow, we can understand that the pipe is entering into the pumps and here it is leaving out. Okay, here it is entering and here it is leaving out, because this is our delivery line, delivery header. This is our suction pipe. Okay, and here they have also taken one pressure vessel. So normally why pressure vessels are requirements, maybe
Maintain pressure.
maintain the air pressure. So this is sometimes called as air vessel also, and this is the standard capacity. We don't need to like bother about the calculation part. Just one standard we have to take air vessel, and we have to just install in our main delivery line. These are the pumps, diesel, okay, jockey. Here they have taken separate pumps: hydrant pump, sprinkler pump, curtain nozzle pump. Now, what is this curtain?
We are not using these things. We're using main electrical pump.
This is main electrical pump only. Hydrant and
because they split it into hydrant sprinkler. Usually you have one main electrical pump.
yeah, sometimes you can go with two hydrant, two electric pump also, and two diesel, one jockey pump. It depends actually. Now here you see after going to the delivery pipe. Now here you can see one connection is coming from the fire brigade inlet. Now first let us see the fire brigade inlet. This is the fire brigade inlet. For example, this is the four-way fire brigade inlet point. One point is going to the tanker inlet pipe. That means suppose directly it is entering into the tank, our firefighting tank, and one pipe is coming. Okay, one pipe is coming directly to our main header line. You can see here two lines are coming to the main header line. Okay, and one is the draw out pipe. So maybe sometimes for draw out connection also you will see in the fire brigade or bridging inlet. So this is that line. But here you can see one line is directly entering into the firefighting tank and one line is directly entering into the main header line. Now, why we require this line means, just imagine if we use our common sense, if I'm waiting for my tank to fill and my system to activate, just imagine what will happen. The building will catch fire, and obviously, whatever the like devastating has to occur, it will occur. So that's why always it is recommended that one line we should directly enter into our main header line. Now you can see this line is directly entering into the main delivery header. Suppose if fire occurs, now electric pump will stop. Okay, jockey pump will stop, but diesel engine will start. Now when I'm charging my line, okay, with water. So what happens? This diesel pump will push the water from here, and it will take the water wherever it is required. So that's why this fire brigade inlet connection is very important. And after certain time, maybe 30 minutes, 60 minutes, or 15 minutes, this tank will fill out. Okay, this tank will be filled, and but our main line will like our main what you can say, whenever the fire occurs, because of the diesel pump, we can use this line. Okay, because it will be already charged only. So we just need the pump to start, and just it can take the water wherever it wants. So this is about this fire brigade inlet connection. Then you see here the three lines are going. Main three lines are shown here. So one line is going for the curtain nozzle. Now what is curtain nozzle means? Curtain nozzle is also something where we are using the curtain nozzle means, suppose sometimes there are two buildings, and there will be a bridging between these two buildings. So to protect that particular area, we use the curtain nozzle. Okay. Designing is same only, like the same,
Similar to the sidewall sprinkler in the hotel.
not
Similar?
sidewall sprinkler. It will be used near the, how can I say, this can be used. Suppose there are two buildings and you have one connecting point, bridging connect, one bridge is there to connect two buildings. So those places we have to use. Actually, this curtain nozzles. Suppose this is block number 1, okay, and there is one block number 2. So there are two blocks, and there is one interconnection point here. So
like a bridge.
yeah, like a bridge. So normally curtain nozzles are used in this. This is the first what you can say application of curtain nozzle. Sometimes it is used in the basements also, and in the basements they will be used with the deluge system. Suppose sometimes you can see you will go with the deluge system. Deluge, here also they have done the same thing. They have connected this deluge system with what you can say the curtain nozzle, and only in the basement area. They have connected only in the basement area. So in the basement area also they might be using in the area where the criticalness is high. Okay, where the area is very critical. Otherwise they will not use, and this system also works like a deluge system only. So here they have shown one curtain nozzle, one sprinkler line, and again in sprinkler they have shown two color. One is going to the upper floor, one is going to the basement floor, and one line is showing to the hydrant pipe. This red color line is going to the hydrant pipe. So here you can see there are three pipes are coming, one for hydrant, one for curtain, one for sprinkler pipe. Now yeah, two sprinkler, that is like they have divided. For basement they have shown different color, for main floors they have shown different color. Now here you can see the pipes are going. So with this drawing you can understand easily how many floors are given. So
can we go to the hydrant pump a little bit? Hydrant pump.
This is the hydrant pump.
Okay, exactly. The discharge is the discharge line. Where is the hydrant pump?
This
okay,
is
hydrant pump. Okay, the above there is purple line and there is the red color. Are they connected in AT?
Yeah, everything will be connected. The main header is connected. All the pumps are connected to this delivery header. Diesel, jockey, hydrant, sprinkler, curtain. Then
there is no non-return check valve to avoid water to come to the other side, to the left side. Non-return valve.
This is non-return valve only. This
okay. Yeah, this
non-return valve.
Okay.
So here they have not written. Maybe in legends you will find. Everywhere they have shown the non-return valve. And here they have used one ICV. ICV is nothing but it is an isolation valve. Maybe suppose if you want to do any maintenance work in the delivery line, so just close off this valve and you can do the maintenance work. Okay, here you can see how many floors. Here there are given 5 floors. This is the 5-floor building, ground, basement and second basement. In the second basement, all the pumps and all are kept here. And in the second basement, they have shown the 4 FHCs. That means 4 hydrant system are connected here. And this is connected here. All the hydrants are connected with this red line. Okay, and it will go up to the final floor. And in the final floor, they will show one arrangement, air vent. Okay, this is like one air vent system. Air vent is shown here. And in the same way for sprinkler, you can see this is the basement sprinkler. This what is this color? Brown color is for the basement. Only till basement it is shown here. See, this is still basement it is shown, but another color, green color, this is the upper floor sprinkler. Just follow where it is going, and you can see here it is going here, somewhere here. See, every floor, this is the zone control valve, and this is the drain pipe. Okay, here only the drain pipe is coming, and how they have connected, whatever the sprinklers are there, they have just make one ring type of thing here. For each and every floor, they have done the same thing. One hydrant line is going, one sprinkler line is going, one drain line is going. All the lines are parallel here. Sorry, all the lines are separated. See, this is my main header pipe, and to this main header pipe, you can see one hydrant is going and one sprinkler is going, and to this sprinkler only drain is connected. Okay, just by seeing this particular, just a minute, something like this is connected. One is going to the sprinkler system, one is going to the hydrant, and this particular is the like drain line. If you see, observe closely, this is also, one is the hydrant, one is the sprinkler. To the sprinkler, drain line is connected. Now this is the same thing follows up to the 5th floor, and they will use one again the air vent here, and here they have used one terrace pump also, booster pump. They have shown that also, and this, why they are using this booster pump means to provide pressure to the final floors like 5th floor or 4th floor. Only 1 or 2 floor.
This is for the water supply boss, right?
Yeah, this is the only water supply. Draining is
it will give the upper 3 floors, and 5, 4, and 3, because gravity will not work.
Yes. It's depend actually, whatever the final floors, and drainage is coming out directly, and it is going directly here, connect to the drain channel. Now, wherever the drain channel, according to the plumbing, you have to check and just connect it to the drain channel. So this is the standard, and here you see one line is going to the external ring main also. Now this is the yard hydrant. So maybe in this building there are 5 yard hydrants. So they have shown here. See, from the delivery header, one line is going to the external hydrant, one line is going to the internal hydrant, one line is going to the sprinkler, one line is going to the curtain nozzle. From only you have to take one delivery header and you have to supply. And there is also one testing header is shown here. See, this is the testing header. Let us see where it is going. This testing header is coming somewhere here, and it is connected with the fire pump. 1 minute.
It should go back to the tank, boss. Water test tank.
Yes.
Back to the tank fire.
It is
tank.
going back to the tank only. See, it
yes,
is.
and there is a flow meter for testing and the pressure valve and the flow meter.
They have just shown the only they have shown how these test headers are connected.
It is missing. There is a flow meter and there is a pressure gauges.
Just they have shown the line only. They have maybe.
Yes,
maybe
I have tested this by myself.
Maybe you will get somewhere here. So in the you need to check, and some connections for the flow switch assembly or zone control valve is shown here. Plan of fire hose cabinet. In most of the project, you will find the fire hose cabinet like this only. It is the standard one. And elevation front view, this is the fire hose cabinet. Some things are, this is one of the type, and here you can see legends are shown here. Some legends are shown here. Okay, now there is one more drawing here. So you see this drawing. So this is just one fire schematic drawing. I will show you the different schematic drawings also. This is one fire legends actually. Some block diagrams are given here, like how the pipes system layout, fire alarm. Okay, this thing is not required. Here you can see zone control valve assembly is shown here. Okay, how the zone control valve looks like. So this is also zone control valve. Channel support. Suppose if you are supporting any channel, how to support the channel. This is one drawing, and this is the sprinkler head. This is the sprinkler head. This is the pipe section, and how it is connected to the slab, that is shown here. This is a very good actually drawing. This is one very good AutoCAD drawing where you can get lot of references here. Details of,
What about the pump and the foundation? The pump, is there
I
any
think it will
inertia?
come. It will come.
Is there any inertia base or?
I think it will come here for pump also. It will be there. This is fire extinguisher drawing. And see, this is the pre-action valve. This is the pre-action valve system is shown here. And this is, I think, Cleve's hanger. Now, this is the one which is mostly followed. Okay, like in most of the project, you will find this hanger supports only. Like this is the pipe size, rod size in inches, in mm. And some numbers are written A, B, C, D, E. Like this particular A, B, C, D, E, you will get the distance, like how it is connected. So this is one, and distance between hangers are also shown here. 3000 mm means how much it will be? 3 meters.
3 meters.
3 meter, 4 meter is shown here. Okay, so this is reference for you. Suppose if you want to check any distance between and all, you can check this particular document also. And in the same way, sprinklers, how the sprinklers are dropping, how the pipe is dropping, this is shown here.
But there's a limitation also for the drop of the sprinkler, 30 something.
This is just some block diagrams actually. It is not necessary that you should follow this one only. I'm just showing you fire department connection, how it is connected, and sprinkler head. This is the sprinkler head, and this is the pipe section connected to the sprinkler. This is the slab rod is shown here, and this is the fire hose reel assembly, fire hose cabinet. One type is shown here, and this is pendant and upright spray sprinklers are shown here. Okay. Next, you can see equipment schedules. Okay, so many things are given. Just you can check this, and so many things are given here. I'm just checking any fire pump room. Street fire hydrant. This is the yard hydrant. See, this is the yard hydrant connection is shown here. And after that, zone control. Again, the zone control valve and fire cabinet details. So many things are given. This is tank connections. This is the sprinkler. Okay, this is one sprinkler is given here. This also you can check. Okay. This is the fire. I think this is the fire FM200 connection. See, but it is given in 3D. Okay, view. Like that, there are so many things given here. So I will just send you this also. And there are a lot of schematic drawings. We will discuss that also. Okay, in our upcoming.
Can you send whatever you send in AutoCAD?
Yes, yes.
CAD 2010, please.
2010. Okay.
It's not. It will open for everybody.
2007. I think I have drawings in 2017. I need to convert it in 2007. I think so. 7 or
just save as same name, but to
yes. I will save it. So anyhow, just you check this, and I was working on this project actually. So there are some mistakes here. So we will discuss this also later.
What is this? What is this project was?
This project is actually industrial project. So yesterday, like I have shown, that it was incomplete. Okay, actually, still he has to complete. Actually, he has completed that. And now I have to check this hydraulic calculation here. Some mistakes are given here. Like what is the mistake here given means the lines are separated actually. See, the yard hydrant is entirely separated with the main delivery line. So this thing I need to work out, and I have some meeting also like day after tomorrow for this project only. So let us see what will happen. We will see that.
What is the mistake in the outdoor hydrant pipe? What is the mistake? The red color?
No, the mistake is that here what has been done means this line, you can see these two lines. There should never be two lines. Okay. You have to take one delivery header. Just see here.
What is the delivery header? This one.
See here, you can see only one delivery header is there. To that delivery header, all the lines are connected. But here, what is happening? There are two delivery headers. So one is going to the yard hydrant, one is going to the sprinkler and hydrant. So this is wrong concept.
The pipe size,
If fire
pipe
occurs,
size is the same.
pipe size is okay. But if fire occurs, then where water should go? Should it go to the yard hydrant or should it go to the sprinkler system? That is the main thing actually.
I think in the yard, normally didn't any fire both time outside and inside.
Yeah, that is the thing. But actually, it is see here. Here, what they have done one mistake here. Fire brigade inlet connection they have connected with the yard hydrant. Suppose if any fire occurs,
No, it's wrong.
yeah,
This is wrong.
this is wrong actually. Only what
It should go to the main discharge. There,
see
there.
what has to be done means just move this pipe little bit here and connect with this main pipe. Then it will be right. Why means because we can understand that this is the header line and from this header line, one pipe is going to the yard hydrant. Now, whenever if the okay, not only like this we have to do, but you have to take the main header line. Just observe this drawing. Here what they have done, they have taken the delivery header and to the delivery header only the inlet, what you can say, this brigade inlet connection is connected. So this is a little concept. So I am working on it. So my task here is to submit the hydraulic calculation, like the allied calculation. So, but I found that the initial of this project is only wrong. So we cannot submit the hydraulic calculation. So they are changing it. So after that, we will see. But these things are fine only because it is not that much. Anyhow, I will discuss this later with you guys once everything is done perfectly. Okay, then. So we will stop here today only. And I think tomorrow I can.
Boss, about yesterday's MNT file. Did you check this or no?
Oh,
MNT schedule.
Yes,
MNT software.
I forgot only. Today I will check it. Actually, I forgot yesterday.
It's not open. It's opening, but it's not doing the calculation.